Hi, welcome to today's class on my lesson teacher. Today's class is a continuation of our previous classes on number-based system for senior secondary 1. In today's class, we shall be looking at the following objective, which is to carry out operations involving addition, subtraction, multiplication and division of numbers in different bases. At the previous classes, we were able to convert decimal fractions in other bases to base 10, of which at the end of that class, I did give you an assignment which says you are to convert 24.042 base 5 to base 10. We'll have to look at the assignment. You have to compare it with mine to see if what you actually did was the correct thing. Now, at the previous class, I said in order for you to convert 24.042 base 5 to base 10, you have to first of all expand this digit as a multiple of the base all raised to the power based on their place values. That is 24.042 base 5 can be expressed as if this has a place value of 0 and 1, while this from the decimal point to your right takes the place value of -1, -2 and -3. You agree with me that this becomes 2 times 5 to power 1 plus 4 times 5 to power 0 plus 0 times 5 to power -1 plus 4 times 5 to power -2 plus 2 times 5 to power -3. And when you simplify this, this is going to give us 2 times 5 plus 4 times 5 to power 0 is said to be 1 plus 0 times 1 over 5 plus 4 times 1 over 5 squared, and 1 over 5 squared is said to be 1 over 25 plus 2 times 1 over 5 raised to power 3, and 5 raised to power 3 is said to be 125. Let's simplify further. This is going to give us 2 times 5 is 10 plus 4 times 1 is 4 plus 0 times 1 over 5 is 0 plus 4 times 1 over 25 is 4 divided by 25 plus 2 times 1 over 125 is 2 over 125. So when you simplify this further, it's going to give us 14 plus, you find the LCM of 25 and 125, and the LCM of 25 and 125 is said to be 125 because 125 is a multiple of 25. So 125 divided by 25 is said to be 5. 5 times 4 gives you 20 plus 125 into 125 is 1. 1 times 2 is 2. So this can be simplified to be equal to 14 plus 20 plus 2 is said to be 22 over 125, which is equal to 14 whole number 22 over 125. So compare my solution with yours and see if our answers correspond. But this is the answer you will get, all in base 10. Now let's go back to today's class. just like I said, today's class we shall be dealing with the basic operations involving number-based system. That includes addition, subtraction, multiplication, and division. But for today's class, we shall be looking at the addition and subtraction operations in number-based system. Now, example 1 says we should simplify the following. How do you add in number-based system other than base 10? Example 1 says we should simplify the following. 234 base 5 to be added to 434 base 5. Before we go into the addition of numbers in base 5, let's have a recap on base 10. Let's remind ourselves on addition of numbers in base 10. Remember that if you have numbers like 659 to be added to 372 in base 10, or in the normal addition that we know, we always start from the units section. If this is units, tens, and 100, by adding 9 and 2, we said 9 plus 2 is 11. We'll carry 1, write 1 and take 1 up, and 1 plus 5 will give us 6, plus 7. 6 plus 7 is 13. You write down 3 and carry 1. 1 plus 6 we said is 7. 7 plus 3 is 10. You write down 10. Now, this is what we were taught in primary school. But actually what you are doing is that you are solving in base 10. And being that you are solving in base 10, digits of base 10, remember, includes 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So what we actually did was, by adding 9 plus 2, we said 9 plus 2 is 11. But since 11 is not a digit in base 10, all you do is divide that sum by the base. Write down the remainder and carry the multiple up. 9 plus 2 gave us 11. 11 divided by 10 is said to be 1, remainder 1. So what we actually did was to write down 1, which is the remainder, and carry the multiple up. And 1 plus 5 gave us 6. 6 plus 7 is 13, of which 13 is also not a digit in base 10. So dividing 13 by 10 gave us 1, remainder 3. So you write down the remainder and carry the multiple up to the next higher digit. 1 plus 6 gave us 7. 7 plus 3 is 10. And so 10 is also not a digit in base 10. So when you divide 10 by 10, it gives you what? 1, remainder 0. You write down the 0 and take the 1 up. And 1 plus 0 is 1. And that's how we got 1031. So this is what we are going to be doing in other bases. Now, back to addition in base 5. How do we add this? We are going to add it based on what I just did in base 10. This is going to be 234 base 5 plus 434 base 5. Let's add together. 4 plus 4 is said to be 8. And since 8 is not a digit in base 5, what do? Remember, digits in base 5 includes 0, 1, 2, 3, and 4. digits higher than this are said not to be in base 5. So when you add 4 plus 4, it gives you 8. Divide it by the base, and what do you have? 8 divided by 5 is said to be 1 remainder 3. So you are going to write down the remainder and carry the multiple up. And we'll continue adding it in this way. 1 plus 3 is 4. 4 plus 3 gives us 7. But 7 is not a digit in base 5. So we are going to divide 7 by 5. And 7 divided by 5 will give you 1 remainder 2. You write down 2, which is the remainder, and take the multiple up to the next higher digit. 1 plus 2 is 3. 3 plus 4 is 7. But 7 is still greater than base 5. So you are going to divide 7 by 5, which gives us still 1 remainder 2. I'm going to write down 2 and take 1 up. 1 plus 0 is 1. But 1 is a digit in base 5. Then I'll have it as this. So this becomes 1, 2, 2, 3 base 5. So this is how to add in number-based systems. Let's take another example. B says we should add 101 in base 2 to 111 base 2. Take the same procedure and you will get your answer. That is 101 base 2 to be added to 111 base 2. Remember, digits in base 2 are said to be just 2, which is zeros and 1. Okay? So any digit other than this, you have to first of all divide it by the base before you move ahead. So 1 plus 1 gives us 2. But 2 is not a digit in base 2. So we are going to divide 2 by 2. And 2 divided by 2 is said to be 1, remainder 0. So I'm going to write down 0 and carry 1. In your junior secondary, you were taught that 1 plus 1 in base 2 is actually 10. But this is how they got the 10. By dividing 1 plus 1, which is 2, 2 divided by 2 gives us 1 remainder 0. So this is what your teacher never told you. I think maybe it's because of your intellect as at that age. Now let's continue. 1 plus 0 is 1. And 1 plus 1 is 2. But 2 is not a digit in base 2. So we are going to divide it by the base, which is 2 divided by 2 is 1, remainder 0. So I'm going to write down 0 and carry 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 is not a digit in base 2. So 3 divided by 2 is said to be 1, remainder 1. And I'm going to write down 1 and carry 1. 1 plus 0 is 1, and I'll bring down the 1. So 101 base 2 plus 111 base 2 is said to be 1100 in base 2. Let's take another example that says we should add 675 base 8 to 564 base 8. Let's arrange them in the same order. 675 base 8 plus 564 base 8. We are going to take the same procedure by adding, and if our sum is greater than the base, we divide by the base, write down the remainder, and take the multiple to the next higher value. So 4 plus 5 is 8, is 9. I beg your pardon. And 9 is not a digit in base 8 because digits in base 8 includes 0, 1, 2, 3, 4, 5, 6, and 7. So 9 is not a digit in base 8. What we do then is to divide 9 by 8. And 9 divided by 8 is said to be 1, remainder 1. So I'm going to write down the remainder here and take the multiple to the next higher digit. 1 plus 7 is 8. 8 plus 6 is 14. But 14 is equally not a digit in base 8. So I'm going to divide 14 by 8. And 14 divided by 8 is said to be 1 remainder 6. So this gives me 6. And I'll take the 1 up. 1 plus 6 is 7. 7 plus 5 gives us 12, of which 12 is not a digit in base 8. So I'm going to divide 12 by 8. And 12 divided by 8 is said to be 1 remainder 4. I'll write down the 4 and pick my 1 up here. So 1 plus 0, it gives me 1. So 675 base 8 plus 564 base 8 is equal to 1461 base 8. Let's take some examples on subtraction. Next is subtraction operation involving number-based system. And we are asked to simplify the following. 1131 base 6 minus 455 base 6. Let's also go back to base 10 and carry out the normal subtraction that we already know, and that is also applicable to subtraction in other bases. For example, if we are asked to subtract 900 minus 737, how do we do this? Ordinarily in base 10, let me add one more digit. Let this be 4 and 2. Let's say 9004 minus 7372. When you are subtracting, you subtract the lower digit from the higher digit, right? That is 4 minus 2 in base 10 is said to be 2. Okay? And 0 minus 7, it cannot. So we have to borrow 1 from the next higher digit from the digits in the next higher place values before we can subtract. But since this is equally 0, we have to go down to the next higher digit to borrow. So we borrow 1 from this, as it is called. This becomes 8, and this becomes 10. Now that 1 you borrow, we said it is 10 because of the number-based system we are dealing on, which is in base 10. So whatever you are borrowing is equivalent to the base. That is why what we borrowed here, which is a 1 digit from the higher place value, is equivalent to the base of that place value, which is 10. So this gave us 10. And now, since this one has 10, it can now borrow 1 to the next lower digit. So if you borrow 1 from this, it becomes 9, and this becomes 10. You can now subtract. 10 minus 7 will give you 3, and 9 minus 3 will give you 6. 8 minus 7 will give you 1. So this is equivalent to 1632 in base 10. Now, let's go back to base 6 and do same thing. I'm going to erase this. Now back to the subtraction in base 6. That we are to subtract 455 base 6 from 1131 base 6. That is 1131 base 6 minus 455 base 6. Now, we are to start from the right hand side. That is 1 minus 5. 1 minus 5 cannot, because 5 is greater than 1. So what do? We'll borrow 1 from the next higher digit. This becomes 2. that one we are borrowing is equivalent to the base. Remember what we did in base 10? So the one you borrow is equivalent to 6. So this is 6. 6 plus 1 now becomes 7 and is greater than 5. You can now do your subtraction. I'll come again. The one we borrowed from 3 is equivalent to the base. That is 6. When you add it to 1, it becomes 7. Now 7 minus 5 gives us 2. So that is the trick. This now is left with 2. 2 minus 5, it cannot. You equally borrow 1 from 1. This becomes 0. And the one you borrow is what? 6. So this becomes 6 plus 2, which is 8. 8 minus 5 is said to be 3. 0 minus 4 cannot. You borrow 1 from this. This becomes 0. And this becomes 6. So 6 plus 0 is 6. 6 minus 4 is said to be 2. So our subtraction gives us 2, 3, 2 in base 6. Let's take another example. That we should subtract 2, 4, 4 from 4, 2, 3. I believe at this point you must have gotten the trick in subtraction operations involving number-based systems other than base 10, which we already know. So let's do this together. This is 4, 2, 3 base 5 minus 2, 4, 4 base 5. Now when you subtract, let's do it together. 3 minus 5, 3 minus 4, it cannot. You borrow 1 from 2, this becomes 1. And the one you are borrowing is equivalent to the base, which is 5. So this becomes 5 plus 3. And 5 plus 3 is said to be 8. 8 minus 4 is said to be 4. 1 minus 4, it cannot. You borrow 1 from 4. This becomes 3. Add it here. This becomes 5 plus 1. And 5 plus 1 is 6. 6 minus 4 is 2. Remember, whatever you borrow from the higher place values is equivalent to the base you are operating on. That's why in this case, whatever we borrowed is said to be 5. Now 3 minus 2 is said to be 1. So our answer now becomes 1, 2, 4 base 5. Let's take more subtraction. 1, 1, 1, 1 base 2 minus 1, 0, 1, 1 base 2. We are still going to apply the same principle in subtraction. This now becomes 1, 1, 1, 1 base 2 minus 1, 0, 1, 1 base 2. Now you subtract. 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 0 is 1. And 1 minus 1 is 0. So our answer becomes 1, 0, 0, 0 base 2. It is not necessary for you to put this 0. Let's take more examples. This example is on base 9. We are going to follow the same procedure that we have been taking. And this becomes 6, 7, 5 base 9 minus 3, 6, 8 base 9. We follow the same procedures in subtracting by saying 5 minus 8, it cannot. You borrow 1 from 7, this becomes 6. And whatever you are borrowing is equivalent to the base. So this becomes 9 plus. Okay? So 9 plus 5 gives us 14. 14 minus 8 is said to be 6. 6 minus 6 is 0. So this becomes 0. And 6 minus 3 is said to be 3. This is our answer in base 9. That is 675 minus 368 all in base 9 is equal to 306 base 9. Let's solve another example. Now in this example, it is a combination of both addition and subtraction. In solving this, you can either add up the first two terms, then whatever you get as your answer, you subtract the last term from it. Or you can just take the 3 together and you will still arrive at the same answer. That is 1 0 1 0 1 0 plus 1 1 0 1 1 minus 1 0 1 0 1. Now what I'm going to do is I'll take the 3 together. By adding the first two and the answer I get, I subtract the last one from it. So 0 plus 1 is said to be 1, and 1 minus 1 is said to be 0. So this is equal to 0. 1 plus 1 is 2, but 2, remember, 2 minus 0 is 2. And since 2 is not a digit in base 2, we have to divide it by 2. So 2 divided by 2 is said to be 1, remainder 0, or 10 as you may call it. You write down 0 and carry 1. 1 plus 0 is 1, plus 0 is still 1, minus 1 is said to be 0. So this becomes 0. And 1 plus 1 is said to be 2. 2 minus 0 is still said to be 2. And 2 divided by 2, because 2 is not a digit in base 2, 2 divided by 2 becomes 1 remainder 0. We write down 0 and carry 1. 1 plus 0 is 1, plus 1 is 2, minus 1 is 1. And then 1 plus 0 is 1, minus 0 is still 1. So this becomes 1 1 0 0 0 0 in base 2. That brings us to the end of today's class on addition and subtraction operations involving number-based system. In our subsequent class, we shall look at the next operation, which is on multiplication and division of numbers in different number-based systems. But before we go, let me give you an assignment. You should try this. That you should simplify the following. A 1 0 1 1 base 2 plus 1 1 base 2. B 6 0 1 base 7 plus 7 6 4 base. No, it can't be that. Plus 2 6 4 base 7, and C 783 base 9 minus 255 base 9. So I hope you should be able to do this in preparation for our next class. Thank you very much for being active in this class. We advise that you subscribe while watching and also share with your friends and like our videos. Do have a nice day and see you soon.